Right, we'll just give everyone a couple of minutes to join us. We're a little early yet, so we're just testing the live stream, make sure all is well.
If it's not, we can try turning it off and on again.
It's always going to work that every time. There's probably some spook in the system somewhere anyway. Need to sort that out. Maybe it's Blinky.
It's always Blinky.
He's there just keeping an eye. Okay.
I'm going to stare at Blinky the entire time and wait for his eyes to start moving, follow you around.
It's the sound. It'll be changing color all over the place. So if we shout too much. Right, we're just on 1:15 now, so we'll give people a minute to join us, and then we'll make a start. Okay, so it's 16 minutes past the hour. I think we'll make a start, if that's okay. Awesome.
Works for me.
Hello and welcome to today's spooky Community Fabric episode. And welcome to Dan, the most recent addition to our solution architect team. Hey, Dan, enjoying your first few months with IP Fabric?
Oh, it's a blast. So much fun.
I'm glad you're enjoying
talking to customers and going out and doing events and all that. So good times.
Excellent. That's what I like to hear. Now, I've asked Dan to join us, not because he's scary, although you could argue, but because he and I were chatting about some of the networking horror stories that we've seen over the years. And we thought this would be a great opportunity to share some of those and perhaps take a look at how network assurance could have helped us out. Now, if you're watching and you've got any questions or comments, just drop them into the LinkedIn chat as we go, and we'll do our best to answer them. So, Dan, your tale of woe, where does it start?
So it was a dark and stormy night. Figure that's how all horror stories need to start.
It's got to start that way.
And in actuality, it was like midday and wasn't too bad outside, but set the stage a little bit. I was working as a network consultant, so going out to customer environments, and project that I was working on was to do a core switch replacement for a customer. So I'm out and we're kind of looking at the existing environment, looking at what we're looking to implement, building out the plan of action. And as kind of a passing comment, they'd said that they've been having these just weird network issues. It's what every network engineer loves to hear. A weird issue occurs randomly. They don't really know what's going on, but it just seems everything goes down for a little bit, and then before they can figure out what's happening, everything's back up again. They've tried looking at WAN links, they've tried looking at bandwidth, they've tried looking at event logs, and they haven't been able to find anything, but they don't really know what it is. It's just kind of gremlin in the system. Well, okay, good to know. We'll keep that in the back pocket, but troubleshooting random network issues, not really in scope for a switch replacement project. So I start digging into the configs and looking at things, and I realize that there's a couple of lines of config that I would have expected to see on a core switch that I didn't, namely setting a root switch for spanning tree. And okay, this is interesting. So we started to dig in and like the joy of networking. So where is it? Well, do you guys have documentation? No documentation. Okay, let's talk about what the network is. So I worked with the client and they started whiteboarding out. So we've got the core switch was in one building, and then they had layer 2 links out to other buildings. They had IDFs in all the different buildings, and they had the same VLANs spanning all the different buildings, all the different closets. Everybody loves stretched layer 2. So, okay, let's see where we can figure this out. So the good old, the hip bones connected to the logged into the core switch. Where is our root bridge? Okay, it's out this interface. Well, okay, where's that interface go? So we're logging in switch to switch to switch. We finally get to a device where it's connected here, but we can't log into it. We get they have no idea what this device is. They have no idea what's going on, but it's in another building. So they take a note of it. We update the configs or get a change in to update the configs on the core device. And eventually the client, their network engineer goes out, traces that patch cable, and finds that there was a archaic switch that was sitting underneath someone's desk. And every time that switch would get bumped, the power cable would get bumped, like, hey, we're gonna clean, so we're gonna move stuff around. Anytime that switch got knocked offline, Spanning Tree had to reconverge and sort out the entire network. And because it's a core network, and then across a layer 2 link to a site, across another layer 2 link to another site, it was at that far end, and then it was MDF to IDF, from the IDF to this desk. So you're going all of these hops to get to the center of the network and then propagating out. So yeah, every time that switch got jostled, the entire network had to reconverge. Wow. Knocked everything off for 2.5 minutes or so. And it was one of those, like, yeah, this absolutely explains. It was like the Scooby-Doo pulling the mask off, just like, oh, archaic switch, it was you all along. But yeah, they were struggling with these issues for years and couldn't find it.
That's a shadow IT job, though, surely.
It's the guy with the mask.
Yeah, it was basically the shadow had installed the ghost switch, and
right, like somebody at some point was like, hey, we need another port here, let's just grab this old switch and plug it in. And nobody, more than likely it had been there for years and nobody knew it was there. Nobody knew to look for it. Nobody could log into it. So yeah, it had probably been there since the dawn of time. And because it was archaic, its MAC address was 1, and it became the root bridge.
And I guess, yeah, not being able to associate the outage with someone kicking the power lead every now and then.
Yep.
Wow.
Yeah, there was because the person that was at the desk, like if they were moving something, like they might not have been working or doing anything, so they wouldn't have figured it out because it was layers out. And by the time that, hey, we're having a problem, people start logging in to look, all of a sudden things are working again. So they didn't even know where to start looking. And even with the various management tools that they had, there was no indication that it was a reconvergence.
So I guess once you find that, how did you go about resolving it?
The fix was easy. It was just setting the root bridge on the core switch. Done. Now our core will automatically take over. But the other thing that was big with that was not knowing, because we couldn't get into the device. I guess we could have looked at the spanning tree settings as far as the root election, but just making sure that there wasn't a priority that was set on that device or resetting it. And I think they ended up, once they knew the device was there in the first place, like, we're going to just pull this entirely. Because we can, if they need the extra port, they can get another drop run, or they can solve that problem other ways. But random managed switches that aren't managed by IT are problematic.
Yeah.
But
yeah. And again, I suppose that's the question of knowing what's there, right? That's making sure you're fully aware of everything that's in the network, that it's documented, and so on and so forth.
Exactly. Knowing that it's there, the documentation, the very few people document layer 2 and spanning tree information anyways. So not having a topology diagram, not having that stuff to quickly find, meant we had to spend, I don't know, half hour to an hour just stepping through, log into a device. Okay, what's the adjacent one? And then because I was a consultant, I didn't know the environment. It's here's the device name. Where is this device topographically? Where are we going? Where's tracing this through so that we can understand what we were working with? And yeah, just having no idea where the route was, what we were connecting to, what was going on. It was perfect storm.
The amount of time that must have taken, the amount of effort and concentration of people's minds and whatever else, that was a very expensive fix.
Well, and it's for what effectively was line of command of a STP priority, really easy fix. It took us probably all in maybe an hour or two to track down and figure out how we wanted to resolve. But the bigger thing was 2 minutes of outage every couple weeks, every couple months, right, for years. Like this, it was because that layer 2 network spanned the entire I don't know, 7 buildings, 8 buildings. You're knocking out thousands of people for a couple minutes. It was a nuisance problem, but it was never something that they were able to track down. So yeah, years of nuisance.
And I guess I mean, some would argue, of course, these days, looking at it, that you would never design a network that way or build it that way, and they'd have a fair point. But obviously, times were different then, right?
Well, even now, there's still plenty of spanned layer 2 networks. Like this is the ongoing debate where, sure, it adds some convenience to do, and there's some arguments that people will make for stretching layer 2 and having those large networks. There's a whole lot of counter arguments to that, namely spanning tree is problematic, and then the way that broadcast, like there's a lot that needs to be considered there. But it's also the joy of just network design, where there are some valid situations where you might need to do stretch layer 2, and there's so it's for as much as a network engineer, you might want to go, no, this is a horrible idea, we should never do it. It's still going to happen. There's still going to be some considerations where it does. And then we need to be able to understand it. We need to be able to support it. And there's just environments where that's the way it's set up. And you're not going to be able to fix it all at once. You need to be able to work with it until you can get to that ideal state.
I think you touch on something important there, that network design more generally, it's about pragmatism, right? It's about being able to give the user the experience they need to have, using the technologies in the best way you can. And what that one's done is the user has had a requirement to have this VLAN everywhere, and that's all fine. So long as you build it within the correct constraints, and obviously that's the bit that broke down right there. So
exactly.
Just go on then. I'm gonna ask you the question. Here's the plug, right? How would we have been able to help with that?
Oh, so this is the fun part. This is the part that when I first kind of learned of IP Fabric, this is what makes IP Fabric awesome. So coming from a consulting background, oftentimes you get dropped into environments with very little information. So the first thing is just the dynamic topology diagrams. Everybody likes to be able to just look at something, the way that you wrap your head around it. Visual, picture's worth 1,000 words. So right off the bat, having just a topology diagram of the way that the sites were laid out, how things were interconnected, all of that stuff, that would have been extremely useful. Secondly, IP Fabric, we can actually display per VLAN where your spanning tree configs are, where's your route, what are your blocking ports, and all that. So within minutes of hey, let's figure this out, we could have seen the entire spanning tree topology, where things were, where the route was, and really kind of understood what that environment looked like. There's, from a discovery standpoint, even if we couldn't log into that switch, we could have potentially seen, hey, there's a CDP neighbor here that we can't log into. So the IT department would have known that switch was there. And then from a topology or a kind of a table information standpoint, we collect spanning tree information. We know where the root bridge is. We know spanning tree stability metrics. So before, the only reason why we found this issue was because a question was asked where, well, why isn't a priority setting on this switch? That seems odd. This wasn't I'm looking for it. I stumbled across this completely accidentally. So having that information initially, you get into if they could have seen that the switch was there in the first place, they could have solved this long ago. Would they have known that there were spanning tree stability issues? They could have resolved it. They would have known where to look. They would have had the right information, would have been solved long ago. Or absolute worst case, even if nobody was looking at that, once we got to that point, like I said, hit the diagrams and find that information within minutes instead of 3 minutes instead of 45 plus. So number one, it could have avoided the issue entirely, or shorten the time to resolve. And generally, I mean, this is just a spanning tree issue, but that same kind of set of rules applies. Getting the information about an environment, number one, you can identify problems before they're problems, or in the event that there is something that's happening, you can figure out where much quicker. You've got all the information that you need. You can drill through to find that root cause without having to connect into a device and then the next device and then the next device and run a half dozen show commands and piece things together. So yeah, if not, like I said, if not avoiding it entirely, definitely would have shortened the resolution time.
No, that's cool. I mean, that's the beauty of it, right? You've got the snapshots there that give you the view over time of all of that data. And the one thing you touched on this before, the idea of having state data from earlier points in time as well, being able to track change in state from one point to the next, means that you've got additional layer of information that you would not normally have, even with documentation. So some interesting points there. I'm going to talk about one of mine, and actually, interestingly, mine has a bit of a layer 2 flavor as well, but subtly different. And this was a real horror show. If the customer who I had this problem with is listening, they will know instantly what we're talking about, even probably by now. I was working as an engineer with a customer who deployed OTV between their data centers. Now, OTV is a Cisco overlay technology, right? And what's its purpose? Well, it's to stretch layer 2 between those data centers, but to do it in a way that doesn't involve spanning tree. So it takes that particular complexity away, in theory. Now they had
replaces it with other complexity,
with another layer of different complexity, of course, right? So because it has its own control plane and it needs an underlay network and so on. But the intention here was they had 3 data centers that they wanted to be able to do vMotion between, right? So there's the reason. They wanted this fast failover and for their applications and to be able to do this have this in their VMware environment. And after a few teething troubles, actually, it worked really well. It worked smoothly. Servers in one subnet happily talked between DCs, and they were all fine. But when one dark, stormy night, all that changed, of course. In the dead of night, we were working on some failover testing. First taking out individual routers in the OTV, and then we got to dropping circuits between some of the locations just to make sure that everything was doing as it should. And because OTV runs over the top of pretty much any underlay network, we should have been able to just drop circuits wherever, and it should have rerouted via other locations and just done its thing. And so it looked like it was doing that. Pings were fine. We were browsing websites on the same VLAN from one place to another. All looked good, right? So we sort of signed up, so thought that sounds fine. All working as it should do. We did notice one weird little thing, that our radius authentication when we were logging into switches was timing out. It was a bit odd. But the customer was using this creaking old ACS server and basically assumed it didn't like the failover very much. So testing was they put a tick in the box, everything was fine, and we moved on. One of the circuits was being relocated over the following days, which is why we were doing this failover testing. So they left it down and out of the network, and so left us using the backup path so they can monkey around with this circuit without impacting the live network. Fantastic. Thought everything's fine. Returned the following morning, and we should have known that something was wrong, really. There were these dark thunderclouds over the office and lightning and all the rest of it. And as we opened the doors...
Everywhere else was sunny. It was just as big.
That's it. Yeah, just all this rain coming down. And as we walked through the doors, there was like a deluge of complaints and problems as we came through the steps into the office. Basically, nothing was working. Or they was claiming nothing was working. Everything was down. No one could do anything. It's like, same as you. It's like, what does that even mean? No idea. So, of course, the first reaction was, well, what do we change and what needs fixing? Just
gets to the really big scary part. Now it's like this is the cliffhanger moment.
I know, right? And then the phone rings. So anyway, where were we? Right, no, everything was down. No one could do anything. It was a nightmare. So our first reaction, obviously, was to walk in, restore the circuit that was down, because we thought, well, that'll fix it. But it turned out it wasn't an option. They'd already started the work to move it, so we were a bit stuffed there. So we needed to work out why connectivity was as it should have been. And as we said, ping was fine and HTTP was fine, but anything Active Directory seemed to be a bit shaky. Didn't make any sense. OTV was working.
Tried turning it off and on again.
Well, of course, we tried turning it off and on again, as all of the things, right? But of course, that didn't get anyone anywhere. OTV seemed to be fine. Things were talking. ISIS, which is used to as the routing protocol to exchange MAC address information across the edge, all seemed to be doing what it should. All the information was there. The tunnels were up. Everything seemed okay. But it was only this authentication that seemed to be the problem. So the first thing first. Well, the third thing, I suppose, after doing the turning everything off and on again and doing the stuff, get to the whiteboard and start drawing up what it is, because of course this is all happening on an environment that's documented how it should be, but not how it is, because there's a whole bunch of other stuff there and the old documentation's out of date. Drawing it up on the whiteboard in order to track down exactly what it is that's going on, and to build a path and an understanding of all the bits of the network. And we're checking every port, every interface, every configuration, and everything looks fine. No problem there. Couldn't work out that thing of it only being related to authentication was still troubling us, until we put a Wireshark on the network. Right? Thought, well, what we'll do is we'll sniff what's going on that AD authentication and see what's happening. So we put a Wireshark trace onto the ACS box. And what we saw was we could see the radius stuff coming to the box, no problem. But when it was supposed to go off and connect to the AD in the back end, it wasn't working. We weren't seeing anything on the trace at all. Now, we could see the TCP and we could see the ICMP, but we couldn't see any UDP coming off the thing because it's Kerberos, right? This is using as its authentication, which by default runs over UDP. This is odd. What's going on here? Anyway, go to the other end of things and look to see the ACS end of things. So this was at the Active Directory. We go to the other side of things and have a look. And we see that this Kerberos requests are going out from the ACS box, but they're really, really big packets. They're full, right? For whatever reason, it's padding the packets out to their full size. So these are being dumped somewhere. So there's something going on here. And of course, alarm bells which were sort of faint to start with, are now getting louder and louder because you're saying, oh, okay, I got a packet of a certain size that's getting through my ICMP. That's all good. I'm getting HTTP getting through, but that's TCP. So we're actually negotiating our TCP windows and our packet sizing. But UDP, which is full packet, is failing. You can see where it's going, right? All of a sudden, alarm bells, MTU, screaming across the floor. Everyone knows what the problem is now, but now we've got to try and find it, right? Back to the diagram on the whiteboard and logging into every device step by step. Is it this interface? No, it's not this interface. Is it that interface? No, it's not that interface. And working our way all the way through the network until we track it down to of course, the last interface we tried. The MTU is neither set for jumbo frames or has been increased in any shape or form. It's there at its default, which isn't big enough to take a full packet plus the OTV overlay headers. Found a problem. Fantastic. Soon as we change that MTU, bang, everything's fixed, restored, working. And of course, then it takes 2 hours for everything for the tumult to die down and normality be restored, right? But again, you see now, you've touched on a number of reasons and a number of ways that IP Fabric would have helped you replay, right? All of those reasons, having good documentation, right? Knowing exactly where everything is. We wouldn't have needed to draw the stuff up on the whiteboard. We wouldn't have needed to work out what those flows were because we could have done path lookups, right? And understood end to end which devices were impacted, which interfaces. Having intent validation, being able to turn around and say, actually, track that the MTUs at either end of every single link are consistent, right? IP Fabric has that in the dashboard sitting there waiting for you, right? So every time you run a snapshot, it's checking that for you. And of course, you've got that ability from snapshot to see what's changed and what goes on. It just so happened that a number of weeks later, said customer was swapping out a device somewhere in the network that had failed. And guess what happened? They put that device back in and didn't set the MTU. And therefore had, let's just say, a similar problem. Yeah, I know, right? Because we all learn from experience, apart from when we don't.
The number of times where I've rebooted device and I forgot to save the config on it. You'd figure I'd learn by now, but yeah, there's.
But I think everybody needs a backstop, right? And some sort of thing to fall back on. And on that occasion, we didn't have it either. So. But no, I mean, this is the point, right? I suppose that we get to when you've got that ability to track what things are doing day to day, when you've got that documentation that you always know is going to be up to date, but then you can build these rules that actually proactively check things for you. So you've got standards that are met, so you know that your spanning tree route is defined and where it's defined. Or you know what your MTU sizes should be when you need them set for an overlay. Then you've got that information available at all times, and it's always checked for you, double checked and triple checked.
And I think the fun thing here is really in both scenarios for whatever the issue is, the resolution is basically a single line. Like it's not. The fix isn't complicated. The bigger problem, the more time, the more headache is trying to identify the problem and where it is than the actual fix. The fix, both scenarios, like I said, one line, like super, super easy to do, but it's, trying to hours or in some cases years of not being able to find it.
Yeah. That's
the big part.
It's the needle in the haystack, isn't it? I mean, this is the problem that every network is so complex. There's so much going on that in order to make sure that you can find a problem when it does occur, you need that consistent level of information and documentation about every single part of the network. Otherwise, you're just never gonna know, are you? And the more that you can automate with the actual process of doing the checking and the validation for you, the easier it gets then to cut to the chase. Really, I suppose it's like you said, it took you however many hours to resolve your problem. Same for me, and that's not just the amount of time it takes to solve the problem; it's the amount of time of the outage that it's caused over time. So in your case, 2.5 minutes, however often that cable was dislodged. In my case, 3 hours of a busy trading floor in an organization that really doesn't need to be down. So yeah, it's costly mistakes to make.
So just because I'm going to throw out the softball question for you,
Yeah.
but so speaking of MTU, one of the fun things that MTU brings in, different platforms, different vendors,
Okay.
the way that is Jumbo Frames 9,000 bytes? Is it 9216? Is it like everybody's kind of got their own settings for that? So IP Fabric, if I've got two different devices that have a different value for what Jumbo Frames might be, how do you deal with that?
I suppose the beauty of all of these things is, right, that IP Fabric and its data model is normalized, right? So we go through a process of normalizing the data on the interfaces, and we have all of that available to you. So really the trick, I suppose, is knowing what it should be in order to deliver it from a normalized standpoint, knowing what it should be in order to deliver the outcome, and then creating those intent rules. That's the key. Because once in fact, there's an intent rule. There's actually one built into the platform that tracks that things are consistent at either end of a link. So you don't even need to put a value on it if you don't want to, but it makes sense to, if you've got a standard set across the organization, create that intent rule to validate that as well. So that's really the best answer from an IP Fabric point of view. And again, for any other thing that's similar, like the spanning tree, I mean, just knowing that you've got a spanning tree priority set on every device is going to be advantageous. And because we can then track and find out, because they're set, because we know what they are, where it is that they are, we can indicate those in the diagrams, right? So yeah, I mean, that's the key. Know your network, but you can only know it when you've got the data, and that's always the gap certainly in my experience.
You don't just go through and spend all day updating Excel spreadsheets and Visio diagrams.
I was going to say Visio diagrams, right? That was certainly a huge part of my life. I must admit, and this is an admission, I haven't touched a copy of Visio in 2.5 years, but that's there you go. That says a lot, I think.
And you always had the layer 1, the layer 2, the layer 3 Visio diagrams.
Right.
You had every site, every switch. Here's my OSPF. Here's my BGP information. Yep, making sure all your lines are just right and color coded.
Exactly. I mean, that sounds like a nightmare to me. Just keeping track of that little lot.
It's that could be its own nightmare episode. Is just
maybe that's
here
it.
Is IT documentation. Bum bum bum.
That's a really good point, actually. What we could do, and if you're still with us, hope you are. If you've got any networking horror stories, maybe this is something we could pick up, Dan, right? Share them with us, and let's perhaps see if we can talk you through what IP Fabric can do to help you, because ultimately that's what the product's there for. It's to give you time and give you back some sanity, I suppose, and some way of protecting you from these horrors. Dan, I'm going to thank you for joining me. Thank you for sharing your story. That's awesome. Really good to see how even experienced network engineers like yourself can save time and I suppose money for the business, right, by using the right approach and the right tooling. So thank you for your time.
Thanks for having the conversation. It's a whole bunch of fun to rehash all the the horror stories. But lessons learned.
There are plenty more where those came from, right?
Oh, there's a wealth.
Maybe for the next episode then. Nice one. Thanks for your time, mate. And thank you.
Thank you.
Everybody for listening.